All right, today in class we did chapters 1.1 and 1.2. 1.1 is all about lines, planes, rays, and naming them. And then 1.2 is about measuring segments. So we're going to kind of go through some of the notes we did in class, and then I'm going to go through the notes from class, but going through some of the homework problems. Through class, some of the notes we took, some of the things I wasn't 100% versed on. Went home, read some more about it, looked at it, and I'm going to kind of address some of the things in class, some questions that I wasn't quite able to answer. So first, 3 big things about lines. We'll start down here with this one. A line is something that continues forever and ever and ever in both directions. It has no thickness, and it goes through, contains a bunch of points, and we're going to use 2 of those points to name it. So this line right here would be called AB, and above it we draw a line with 2 arrowheads. This tells the reader that, hey, there's a line out there called AB, goes on and on forever in both directions. A ray is a line that continues forever in just one direction. Still requires 2 points to be named, because if we just had ray A, that doesn't tell the reader that it's this ray versus that ray versus this ray versus that ray. Technically, all the ones I just drew in red and the one in purple are technically ray A, but by going AB, we now know that it's the ray that goes from A to B this way. It is important to note that how you label the letters for a ray is important. So this is telling the reader that the endpoint is at A and the ray extends through B, where if I had it going the other way, here's B, here's A, and our ray went this way, we would call this ray right here BA. That way the endpoint is with the correct letter. We don't typically write AB like this. Our arrows typically go to the right. I don't think I've ever seen it written how I just had it. Which then brings us to a line segment. A line segment is a line contained between 2 endpoints, A and B. We would call it AB, and it would just be a line right above. No arrowheads, no dots, no nothing. So technically this dot doesn't need to be there. And that's our line segment. This one could also be called BA and still be the same line. When you have 2 rays that share the same endpoint but go in completely opposite directions, they're called opposite rays. Imagine that. Rays that go in opposite directions. So we've got the endpoint A, and if one of my rays goes this way through B, and then I have a completely opposite one, I might not be able to draw it perfectly, like 180 degree difference, but just kind of assume, like if I were to, I have a computer, I could do this perfectly. For instance, I'll just do it real quick. Well, that was not bad, except for the purple side. So if I had the ray like this, A, there's C, there's B, ray AB and ray AC are considered opposite rays. So we're going to kind of skip over what I have here. We're going to jump to some of the homework problems. This one right here. There's actually 6 line segments in this picture, and there are 6 rays. The rays is the one that I kind of want to address if you were in class today when we get to it. So the 6 line segments. I'm going to come over here. We're going to do this in a pretty organized fashion. Line segment RS. So I'm going to record that. RS. That is the same as SR. We don't need to label it twice. We then have line segment RT. We then have line segment RW, which is the exact same as WR, TR, and SR. We then have line segment ST and line segment SW. The exact same as WT and WS if we read it the other way. Which brings us to our final line segment in the picture, TW. There are not 12 line segments. Again, if you were to be like, well, let's just start the process, start over here at W. WT, that's this one. WS, that's this one. WR, that's this one. So there are 6 total unique line segments in this picture. In the same vein, there are 6 unique rays. So if we start at W, W is our endpoint. We have array ST. This is where we are making a change. I read the textbook. I read some other things about geometry online. So WT, our array right here. W goes through T, goes all the way this way. But WT is the exact same thing as WS, and it's the exact same thing as WR. Those are all the exact same ray. Endpoint of W, they are all collinear, and they're using the same arrowhead. So those are all the same ray. So we're only going to record it once, WT. We then have this ray, where T is our endpoint, TS. And TS is TR. They're the exact same ray, so we're only going to write it once. And then our last ray is SR right there. So there's 3 of them. Our other 3 rays, because we know that there's 6 of them here from the hint from me, we have R this way. So I'm going to record one of them. RS. That's the same as RT and RW. We then have ST or SW. And then the last one, TW. And here's where that arrowhead and the labeling becomes very, very important. Because if we look, we have ray WT and ray TW, same as the other ones, but they're telling us that W is the endpoint here, while the T is the endpoint here. On to planes. So planes are perfectly flat surfaces, but flat does not mean horizontal. Flat does not mean vertical. Flat could be in any orientation. It could be rotated anyway. So if you had like a compass rose, like this, these are lines, of course. These lines, but then you also have this line. Then you have this line. Then you have that line. You have this line. You have this line. You have this line. Just slowly, surely rotating. Same with planes. They're flat surfaces. They have no thickness. And they extend forever in all directions. When we name planes, all it takes is 3 points on the plane. We can also get a little lazy and just call it a specific name. So for instance, in our homework, we're going to look at question number 9. How what are two other ways to name plane C? So this plane over here, this rectangle, is our plane. Its very simple name is plane C. But other ways we can name it could be plane E, B, F, because those are 3 points on the plane. We could call it E, G, F. E, G, and F. Any combination of these 3 letters, or these 4 letters, just using 3 of them, or we could use all 4 letters if we want. So there's 3 different ways: E, B, F, G, E, B, F, E, G, F, B, F, G, G, E, B, are all a lot of different ways to do it. With planes as well, we've got all of them right here. So this top part of the box, that's one of our planes. UXW could be UXV, it could be UXWV. And they want us to name the intersection of a pair of planes. So QRS, so there's QRS, so it's this plane right here. And RSW, so it's this side of the rectangle right here. They end up intersecting right here, because if this red plane were to keep going, red plane like that, the blue plane would like that, and they would perfectly intersect right there. It would be line RS. 19, 20, 21, 22 are similar. They want us to find the planes that create that intersection. So let's pick on XT. So XT is this line right here. Line XT is between this plane right there, this plane right here, this back rectangle. And so I would say XT is between plane XWS and plane UX, and then I think that's T down here, isn't it? Yeah, T. 23, 24, 25, and 26 want us to shade where in this box do we find these individual planes. So let's look at like RVW right here. I'm going to redraw my prism right here. This one's R, this was V, this is W. So RVW is this right side of the box right here. S is a part of it, but doesn't need to be a part of it for the name. Question 25. Draw in my rectangular prism again. Oh yeah, look at that top of the box. Beautifully drawn. I know you're all jealous at home watching me draw these 3-dimensional boxes, and you're just like, one day I'll be as good as Carlisle. U, X, and S right here. So it's the top left boxes, but it's the bottom right. It's not the back plane, because that doesn't go through U. It's not this left plane. It's not the top. It's not the front, not the bottom. It's actually the plane that slices this box diagonally that contains all 3 points right here. Like you're trying to lay a ruler in a box and it just doesn't quite fit. So I'm going to use their drawing to kind of get an even better drawing of it, since their picture is probably perfectly drawn compared to mine. It is right here. 26 is similar. It's what happens if this box got rotated around 90 degrees. So it's kind of hard to draw for 26, so I'll help you out to kind of give you an idea what happened if you draw it. You can make the, oh my gosh, that's awful. I'm not even going to draw it. I'm just going to use the one on the computer because it's just easier because I can, because I'm special. So T, U, and V then would include point S, and it would be this plane right there. The last thing we talked about in class were measuring our segments. So the cool thing about measuring segments is it's just like any algebraic expression. So if I were to take line segment AB and I take segment BC and I put them together, the length of AB plus the length of BC is equal to the length of AC. So if this was 10, this was 20, I could say 10 plus 20 equals the total length of 30. Just like anything you would expect to happen in the mathematical world. Now sometimes this point B perfectly splits a line in half. So if I have A and B, and I have a line split it in half, if I just have a point split it in half, call it C, the point is called the midpoint. Oops. Halfway between A and B. The line is known as the segment bisector, splitting your segment in half. Now, sometimes they don't directly tell you C is the midpoint, or that this line right here, call it CD, is the segment bisector. Sometimes what they do is they put little hash marks or tick marks, and that tells you that this length from A to C is the same as B to C. They are congruent. So if they're congruent, we can solve problems like this. I'm going to erase this so I have some place to work. Say this is 6x minus 7. This one is 5x plus 1. Because both halves are equal, I can put 6x minus 7, and I can set it equal to 5x plus 1. Add 7 to both sides, subtract 5 from both sides. I get x equals 8. Now here's something that you got to be very careful on for tests, quizzes, homeworks, what have you. Make sure that you answer the question. Now I didn't really ask a question on this one because we're just going through our notes, but let's say the question was to find x. If it was to find x, we found the value of x, we would be done. If we were asked to find the length of AC, we would not be done. All we have done is we found x. To find AC, we plug the x value in, and we find that AC is 41. You may even be asked to find AB, the whole length from A all the way over to B. So you can plug 8 in here, we can plug 8 in here. Because it's the midpoint, you can actually know that both sides will be 41, and AB would be 82 for our answer. So make sure that you are fully answering whatever the question may be. So if we look at our homework problems, we're naming the intersection. So where is the intersection? Name the rays. Pair of opposite rays. Just make sure we're answering our questions fully.